Kavya, how was your internals? SC internals. Okay. So what about the others? Lavanya, Lata. The people are not there in the class. Yeah. How many times did I remind you in the class? Plan properly, write your answers. Hmm? See, that is how in final exam also you will be having essay. You can complete one answer and two questions you can write in complete 3 hours and say I did not find time. But that is not how it is, right? So I would request all of you, let's see how you have written also, maybe whether it is a copy paste or whether you have written it on your own. Fine. Okay, let's take the attendance today. Because the attendance is students are less, I want to start with the attendance. Yeah, one thing I found out was Apurva is there in the class. Apurva, M, Harishwini, and someone I don't know, guys. Who is it? Here we are Kumar. Who is that person? Please give your proper name. Apurva M. Yeah, Harishwini. Madam, your answers are not submitted, no? Okay, you also. But the problem is, let me check once again. I have got 84 plus you both is 85, 86. But number of students who are absent are for my test is only 2. So it should be 88. But I've got 86. Anyone else who has submitted to me through mail? Who is that person? Here we are, Kumar. Okay, Ankita Nath. Fine. One person I'm not getting. That who is that Kumar fellow? Please tell him. Anyone knows who is it? Okay, fine. 1, 2, 3, 4. Fine. So just let me copy down your names, guys. Okay, let's start with attendance today. USN 1, 2. Guys, please type in your attendance. Yusuf, 3, 4. 4 is absent. 5, okay, 6, 7, 8. Aditya Pratap Verma, 8. 9, 10, 11. Chakravardhan, yeah, 12. 13. Amoges Bharadwaj, present. 15, present. 16. Okay. 18. Ankit Kumar Singh. Okay. 20, okay. 21, okay. 22, okay. 23. 24. Asim, 24. Bhanupriya, 26. Bhargav. Bhargav Reddy, 27. Shri Harsha, 28. 29. Rakshit, 30. Chandan, 30. Chandan, 31. 32. 33. 34. 35. 36. Sai Kirtana, 37. 38. 39. 40. 41. 42. 43. 44. 45. I don't know, someone is trying to join. One second. Okay. 46. Ganesh. 47. 48. 49. 50. Gurudarshan 50. Yeah, why so many of you are absent? 51. 52. 43. Okay, 48 present, fine. 53 present, 54. Yeah, 55. Harshit Singh. 56. 57. 58. Ishita Pandit. 59. 60. 61. 62. Yeah, I don't know because I'm not getting a request. I'm just getting like someone wants to try to and close the dialog box. But I'm not able to get any request from anyone. Let me, in case if she, let her ask her to try. In case if I get, I will. Okay, 66. I'm sorry, 63, 64, 63 is absent, 64, 65, 66, 65 present, okay, 66 present, 67 present, 68, 68, 69 present, 70 present, 71, 71, Krutik, 72, 73, 74, 75, 76, 77, 78, 79, 80, Sahil, 81, 82, 83, 84, 85, 86, 87, 88, 89, 89, 90. Okay. Let's continue with today's topic, design patterns. So, what are these design patterns? Patterns and pattern languages are the best way to describe best practices, good designs, and captures experience in a way that is possible for others to reuse this experience. So, what does this actually mean is It is a type of reusing technique wherein reuse an abstract knowledge about a problem and a solution. Actually, I had given you some little bit of introduction about it. What does this mean? Okay, so what does this mean is here you have certain problems which are known as well defined problems, and there are solutions for such problems, which are like universally accepted in the sense there is a way in which you can see this solution is best for this type of problem. If it is a client server problem, if it is a distributed application, if it is a what IoT based application, see there are certain types of applications which we can distinguish, right? So we can say for what type of problem what is the solution best, based on people who have already come up with the solutions for such kinds of problems. That is what we say, that there are certain, they describe these patterns or these design patterns, they give the best practices, good design and capture the experience. So people who have already worked on it, guys, I don't know why I'm not getting the request here. Please tell her, whoever wants to. I think it is Janvi who is having that problem. I don't know why. I'm not able to accept her request or some others also, because it is just giving me a message. So please tell her, if I get a request, I'm just getting a message that someone wants to join, but I'm not getting that accept a request. I don't know why. So if I get it, I'll really accept a request. It's only for her I'm facing that issue. It's asking me to close a dialog box. I don't know which dialog box should I close. Okay, I'll continue next class. I will check. So there are certain kinds of problems, and there are solutions for those problems, which are like tried and tested. So if we solve the problems using those solutions, it is like something like you are guaranteed for having a proper solution for that. One second, guys. Your friend is sending a request and messaging me from like anything, but I don't know. Just give me a second. as I give you an exercise. See, so what we said was it is a reusing an abstract knowledge. Okay, so it defines you something like which is already present and you are trying to reuse it. ಇಲ್ಲ ಶಿಲ್ಪ ಅವ್ರಿಲ್ಲಿಲ್ಲ. So it can be, it should be sufficiently abstract to be reused in different settings. Pattern descriptions usually make use of object-oriented characteristics such as inheritance and polymorphism. Basically, it is used for the techniques which is involves inheritance and polymorphism. Okay, so actually there was a design pattern which was introduced by four people. It is known as Gang of Four. So they came up with a number of design patterns, and some of the four of them is known as the Gang of Four, which is developed in their book. So most of the times we use es- those essential elements of a design pattern as four things. And what are those four things? We'll just explain. One is the name, the other is the description, the other is the problem description, and then we have solution description for that, and consequences. So, ma'am, there is five you might ask me. So, name is one thing, description is one, and then you have problem and solution description. That is, this problem description is nothing but the description here, and then we have something known as consequences. I want you to go read through it and the next two slides, meaning what it is. Okay. By then, I'm just receiving your friend's call. Let me take that call, okay? Otherwise, I will be getting hers. Okay. Sorry, guys. Sorry for all the trouble. Okay. So let's start. So the gang of four in this pattern has three things. I'm sorry, the four things. First is the name. The name says the name of the pattern. That is, we give a meaningful pattern name. Then we say description, the description of the problem area that explain when the pattern may be applied. See, what is this design pattern means? There is a solution already available. We try to reuse that solution to that particular types of problems. So there are certain common problems. I said, for example, if it is a client server's communication, then there is a pattern available for it. If you are developing an application for this, or your application depends upon the client server type of applications, or it is related to that, may not be exactly that, then you will be using that such kinds of patterns. So the description of the pattern will tell when the pattern may be applied. Next, we have solution. The solution description of the paths gives the design solution, their relationship, and their responsibility. Here, please understand the design means it is not complete design. It is not a concrete design. That is what they call it as. It is a template of the design solution. So it just gives a template for the design solution. And it also shows here a graphical relationship. Most of the times this design is nothing but a, graphical relationship. Okay. So next we have something known as statement of consequences. Now the statement of consequences, it gives the results and the trade-offs of applying the pattern. So what is the use of this is it will help the designers understand whether or not a pattern can be used in a particular situation. See, it is like the end result is what it is and what and all is possible. That is what is given within our consequences. So when we say, so when we say that a particular design pattern I'm using, whether it is feasible or not, or the consequence steps tells me whether it is applicable or not. What are the pros and cons of using such a design pattern will be given in this statement called consequences. So here the description of solution will always give us what the pattern structure is, what are the participants, who are the collaborations and implementations. So one of the pattern which is given for you is, again it is hanging. So basically you have four things. Here the name, and then you have something known as description, which also involves the problem description. Both of this comes under one particular criteria. Then you have something known as solution description, and then you have consequences. So the name gives the name, description gives the state of object and all of that, and the solution which tells us what are the design solutions. Consequences are something like what are the um, performance, or whether it is trade-offs or results of applying the particular pattern. So you have already read through this. So one for a design pattern, they have explained is something known as an observer pattern. What is this observer pattern is, you have multiple observers for a particular data. Let's say for, see, there is something wherever you are, maybe from this example you will have a get a clear idea about what does this pattern means. Let's take a problem wherein I am having a set of observers. Okay, let's say for example, I have a application wherein there is a data and there is more than one representation of the data which will be viewed by, or there is multiple representations of the data which the end user can view. Let's say for example, this is a data. Okay, there is something known as marks. Fine. So this is A, B, C, D we have given and the subject, and we have certain values for each of them. See, this data can be viewed by two types. One is an observer 1 and the other is the observer 2. So this is one observer 1 and I have another observer 2. So whenever there are, and in observer 1 it shows it's in a pie chart value, and in observer 2 it shows it in a bar chart. Maybe there is another observer 3 which sees the data in a tabular format. Okay, so whenever there are multiple observers associated with the data, then we use this observer pattern. Let's say for example, you also want to, your application also wants something known as a graphical user interface for viewing data in multiple ways. Then you can use this observer pattern. Fine. So here this is what this pattern describes. The name of the pattern is observer. Then the description is separates the display of the state of an object from the object itself and allows alternate displays to be provided. So whenever you have a alternate displays to be provided, then we use this observer pattern. So what is the problem description? In in many situations, we have to provide multiple displays of the state information, such as graphical display, tabular display, and so on. So note all of these may be known when the information is specified. All alternative representations should support interaction, and when the state is changed, all displays must be updated. That is, let's say for example, the data changes. The data changes in the sense there is some update. There is now I am displaying only A, B, C, D. Suppose there is another criteria or the data that needs to be displayed known as E. Then I have to update it, right? It has to be updated in both observer 1 and observer 2. So that is what it is. So when a data is updated, all the means of displaying the data should also be updated. So that is what in the problem description we have been given. Then solution, there are so you can have a solution for this involves there are two concrete classes, two I'm sorry, abstract classes, subject and observer, and two concrete objects known as concrete subject and concrete object, which inherits the attributes of the related abstract objects. So, I can better describe it using this diagram. Okay. So, you have a solution model for this here, wherein you have an observer class and you have a subject class, then you have a concrete subject and you have a concrete observer. Okay, the subject is associated with get state, and as the state changes, the observer value also changes. Okay, so what do they do? The concrete subject, which inherits the operations from subject, allow it to add and remove observers and to issue a notification when the state has changed. So the job of this subject is now, if you understand here, this subject is an abstract class, whereas concrete subject is a concrete object or a concrete object of this class. What is concrete and what is abstract? Okay, it is something known as interface, or you can say inheritance. Let's take for your level, it is kind of an inheritance. So here, this is a subject which will create observers. So in this is a subject, right? So that is represented by this concrete subject object. See, please observe here. So this is what. you have a, so for this subject you have a, how do I give a solution is, I have a concrete subject class. So in order to get the data from the subject, their observers will have to register with them. Okay. So observers will register with them, and whenever there is a state change, they will call the update function, change the state. So this observer here, there are so many observers, right? One is the pie chart and other is the bar chart. So all of them represent a concrete observer object. They will be registered with respect to the subject class. So there can be more than one observer objects with respect to the subject class. Fine. So there will be more than one observers, in number of them, and whenever there is a change in state, that is updated within the update function of the observer. So let's take this example. Let's say for example, this is one subject. Now, there are two observers, observer 1 and observer 2, who have registered to this subject. They get the data, right? They get the data, that is the state. In this state, what is it? A is equal to 40, B is equal to 25, C is 15 and D is 20. So, observer 1 will get this data and represent it graphically. Observer 2 will get this data and represent it through a pie chart. I'm sorry, through a bar graph. Let's say, for example, the subject changes. Changes in the sense, let's say, for example, I get another value or called E, and E value becomes something like 50. Agreed? Fine. So now, if the observer displays the same data, that is the pie chart with 4 entries and a bar graph with 4 entries, is it correct? Is it correct? The observer pattern, will it be correct? Guys, are you getting me? No, right? So the data, there is a discrepancies in the representation or something, right? So now what it will do is, here it observer will call the update function, which will get the state change. Whatever the subject state changes, that is updated by both observer 1 as well as it is whoever observers who have registered with the subject. All of them are updated with the change of state. So when there is a state change, what happens is, again, this bar graph will obviously be updated, right? You have another entry here, something like this. And again, there will be another entry here. Maybe I can say A, B, C, D, and another one here, E. Got it? Any problem which comes under this category will be under, you can use this solution which is there. Which solution? This kind of solution, that is with objects, classes, and inheritance and polymorphism. You can use this and come up with a solution. Did you understand? When you come up with such kinds of solutions, see, when you are using this kind of pattern, you have a ready-made solution to your problem, which is tried and tested. Rather than you coming up with your own problem, which is, I'm sorry, with your own solution, which you don't know whether it is correct or wrong, when you're using such kinds of things, what happens is you're guaranteed this solution. But one thing you have to take care or come up with or be careful is whether it properly suits. Okay, there are certain, that is what we say, consequences. So if there are certain things which you have not taken into consideration properly, then it may not apply to your problem. So one pattern, what you learned is observe a pattern. Similarly, you have around 22 or 24 patterns which are readily available. So whenever you are trying to a solution for a problem, you can check whether any of the solution is already available. Okay, and if it is available, you can use those kinds of patterns for your problems. Got this? Yes? Any doubts? So to use patterns in your design, you need to recognize that any design problem you are facing may have an associated pattern that can be applied. That is, you have to know, okay, whether there is a pattern which is applicable to your problem. So you have to search, you have to go through all the patterns which are available and try to see whether that pattern is applicable to your problem. So some of the patterns available are, one is the observer pattern. That is, there are several objects that the state of some object has to be changed. So that is the observer pattern which you learned. Then you have something known as facade pattern. So tidy up the interfaces to the number of related objects that have been developed incrementally. So you need not have to learn, just learn these observer pattern for your case of as one of the example. So design pattern is actually an important question from your examination point of view. So what are design patterns, what are the advantages of this, you can learn. And one of the pattern is the observer pattern example. You can give this diagram as example, explain that pattern with those four, that is gang of four uh, statements. Okay, then you have iterator pattern. So if you are accessing the elements within a collection, irrespective of how the collection is implemented, you can use the iterator pattern. Then you have decorator pattern, allow for the possibility of extending the functionality of an existing class at runtime. That is, if you're trying to change the functionality of a particular class during the runtime, then you can use the decorator pattern. If you're iterating through a collection of items, you can use the iterator pattern. So these are some of the four patterns: observer, facade, iterator, and decorator. So anything else? Any doubts in this? Otherwise, I'll go to the next topic. Next topic what we have is implementation issues. Now, what are these implementation issues? That is, while you're coding, I mean, it is not basically while you're coding what you're facing, but before beginning with implementation or something like beginning with the task of implementations, what are the three things which you need to be concerned about? One is reuse, the other is configuration management, and the last one is host target development. What do I mean by reuse? Yeah, what do you mean by reuse? Can someone say? Not with this perspective, at least. Yes, guys, what do you mean by reuse? Okay, at least code reuse. That at least you can tell. Yes, Shruti, what do you mean by reusing of code? USN 88. None of you are in the class. Mm, yeah, one use of inheritance is reuse. Let's say we are not talking about that reuse. Yeah, thanks, Ananya. See, like what your friend Ananya is saying, writing the code again and again rather than that, I will reuse the existing function. That is one real good way of telling it. Let's say, for example, one of your nowadays calculating a hmm, square root of a particular number. Okay, do you use the formula and do it, or do you use an inbuilt function to calculate or get the square root? Yes. Most of us, if we want to do sine of a number, we can do the calculation programmatically, right? But do we do that? No, right? We use a function, inbuilt function, which is available in math.h and write our program. Do you agree with that, all of you? Yes or no? Whenever you're doing mathematical operations or string operations also, see, you would have written a program perfect logic for concatenating two strings. But use it while performing or writing an application? No, right? What do? There is a string cat strcat function available. You will use that function and write your program. Why? You will say, see, that is not what my objective is. My objective is to develop a product, and for that product, a small task is concatenation. I will use a function which is readily available and which is perfectly fine. See, when you are using the functions which are already available, like sine function, mathematical functions, or string handling functions, you know that they are implemented, they are tested, and they are perfectly correct. There is no way that those functions can be wrong. But if you write a function, what happens is, yes, you are capable of writing, but imagine the amount of effort required, right? See, if I'm reusing a function which is already available, I will require only 1 2 minutes to do that. If I'm writing it, maybe I will require 1 day to develop it, test it, and integrate it with my program. So that is the one thing of reuse. The reuse, what happens is, if you're reusing the existing components, then or a system, what happens is the amount of effort, like what your friends said in inheritance and all, we were going to reduce the amount of effort as well as cost also, right? Your effort, all that is reduced there. So whenever one thing while a developer faces an issue is while developing a product or during the implementation is whether I will reuse an existing code or whether I will write from scratch. You have to make that decision. Both has pros and cons. Ma'am, just now you said reuse will is very easy or will do so many advantages. But yes, there are certain disadvantages. If you are, see, for example, the sign and display function and all what I said was very simple code. If you're trying to reuse some product, half of it which you have already developed into your code, then what happens is integration issues will be there. That is what you have to that understanding it and trying to put it within your code and seeing whether it will work, all that will take some time. And sometimes what happens is the code what you're reusing is not what you have written. Someone has written it and you are trying to put it in your code. I hope if any of you have tried downloading code from the net and trying to show the project in college, right? Using the project which is available in the net, it is not an easy issue. That's the reason most of you get caught while downloading a project and displaying. The reason is you will not be able to understand what they are written, why they have written, what is the line. Leave off what they have written inside, you will never know how to run that code only. Agreed? Yes? So there are issues with this reuse also. So implementation thing is you have to take care whether you will reuse or whether you will write from scratch. Next is configuration management. The other thing is during the development process, you have to keep track of many different versions of each software component in configuration management system. See, whenever you're developing a code, you have to keep track of the different versions of the code what you have developed. Now, what do I mean by different versions of the code? Let's say, for example, you have written an assignment you have to write. Yeah, first time while to give it to the college or to give it to the class teacher or your subject, you will write some version, copy it. But for studying for the internals, is it sufficient? No, you will get it from another friend. By the time that is over for your final exam, you will have another copy which you feel covers all the assignment questions and is very easy. Do you agree? You have to keep track of all the different versions of an assignment. Yes. By the end of the examination, by the time it comes, you will not know which one to read, which one is the correct one. Maybe that happens with your lab cycle programs, right? Maybe in the manual, some corrections they have told. You would have lost it. By then, your friend will say, some college, some program is very easy. I will give you. Someone explains you some code, you will take that code. By the end, on the day before the exam, you will not know which one to read. Agreed with that? Yes. So configuration management means keeping take care of or taking care of the different versions of the software components what you have developed. See, it is not developed by one single person. There will be multiple people working on the software. So which version is correct, which one is not, you have to keep track of that. That is done within configuration management. Next you have is host target development. Next, production software does not usually execute on the same computer as the software development environment. Rather, you develop on one computer and you install it on a separate one. See, most of the times, the environment on which you develop a software is different from the environment in which you install or their software works. Yes, particularly for applications like mission critical applications in robot or in space stations or in airways system and all, you will be working in a simulated environment. I hope you know what does it mean by simulated environment. But when you install your software on real time system or on the job, what happens is there may be so many issues which you may face. You wouldn't have predicted that we will have faced so many issues or so many problems. All that will happen when you are actually installing or running the software on an actual environment. So implementation should take care of all of this. One is the reuse. Whether if you're reusing the component or developing it from scratch. The second one is configuration management. Keep track of different versions of the software. And the last one is take care of the development environment as well as the target environment in which the system is working. Okay, so this comes under, these are all the implementation issues which are You will learn, I mean, I've given an introduction. Next, you will learn about these topics. Okay? Any doubts in this? Please let me know if you have any doubts. By then, I will just check with the attendance. Yusuf present, USN 2, USN 4 present, 4, Abhishek. Okay, Abhishek absent. Did he send a message? Okay. He sent a message and he is out. Tell him. I marked him absent. Next is 18. Ankit Kumar Singh. Present. 24. Pres- Present. Okay. So 18 is absent. Then 26. Bhargav Reddy. Okay. Then 27. Sri Harsha. Present. Okay. 30. Chandan. 30 USN. Chandan. Absent. Then 36. Sai Kirtana. Sankirtana. Sorry. Abhishek, what is it? When I'm asking, you'll not be there. Okay, Sankirtana 36, absent. Then 40. Sir, please don't tell me this. 42, Fabian. 46, Ganesh. Okay. 50, Guru Darshan. Okay. 52, Harish Kumar. Harish Kumar absent. Okay. Harshit Singh 55. Okay, present. 56, Hemant Reddy. 57, Ishan. 58, Okay. 58, Ishita. Absent. ಆಯ್ತು ಬಂದೆ ಅಟೆಂಡೆನ್ಸ್ ಆಗ್ತಾ ಇನ್ನು ಒಂದು ನಿಮಿಷ ಅದು ಆಯ್ತು ಒಂದು ನಿಮಿಷ 63 ಅನೀಶ್ ಶೆಟ್ಟಿ 64 ಭುವನೇಶ್ 68 71 80 82 Mohammed Saif 80 present okay 82 84 then 88 88 dear when I ask you question you don't reply 89 okay these are the students I have marked absent today thank you guys we'll continue in the next class